Student video number 2. Our objective for today is to find all zeros, including imaginary. Okay, so our polynomial for today is 2x to the 4th plus x cubed minus 5x squared minus x plus 3. The first step to finding the zeros is to figure out the possible real rational zeros. And so by doing this, we figure out our p's and q's. So for 2, it will be plus or minus 1 and plus or minus 2. And for negative 3, actually positive 3, it will be plus or minus 1 and plus or minus 3. The next step is to put our p's over our q's. So this will be positive or negative 1 and positive negative 1 over 2, and also positive and negative 3 and positive and negative 3 over 2. Our next step is to use Descartes' rule to figure out how many positive and negative values we will have. So to do this, we list the signs. So since 2x to the 4th is positive, we put a plus sign. X cubed is positive, so we also put a plus sign. Negative 5x squared is negative, so we put a negative sign. Negative x is negative, and plus 3 is positive. So now we count the changes from positive to negative. So from positive to positive is no change. We have a change here. We have no change here. And we have one more change. So our positive values are 2 or 0. And we count by 2's to make sure that we account for imaginary numbers. And so now we find our negative possible values. So when the degree of the polynomial is odd, we change the sign. So in this case, 2x to the 4th is still positive. X cubed has an odd power, so we would switch that to negative. Negative 5x squared stays the same, so it stays negative. Negative x switches to positive because it has an odd power of 1. And positive 3 stays positive. And so now we have a change from here to here. No change here. One change here. So once again, it's also 2 or 0 possible values. And to find our y-intercept, we plug in 0 for all x values. So if we plug it all zeros into every x value, we would get 3. So our y-intercept is 0, 3. And now to find our zeros, we use synthetic division and try to find a 0 here. So first we will start by using negative 1, and we just copy the numbers of the original polynomial. So it's 2, 1, negative 5, negative 1, and 3. And so we drop down the 2, multiply and add. So negative 2, negative 1, 1, negative 4, 4, 3. And 3 times negative 1 is negative 3. And 3 minus 3 is 0, so we have found a 0 here. Next we will use the number 1. So we use our values that we just got. So it's 2, -1, -4, and 3. And we do the same thing, multiply and add. So it'd be -1, -2. Wait, did I mess up? Oh, I started in the wrong place. So we bring down our 2. 2 times 1 is 2. So this is +1. 1 times 1, -3. And -3 times 1 is -3. And -3 plus 3 is 0. So 1 also works and gets us a 0 here. So now our equation is 2x squared plus x minus 3, because we have lowered the power by 2. And so now to find our imaginary zeros, we plug that into the quadratic formula, which is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And so if we plug in our values, we will get -1 plus or minus radical 1 minus 4, 2, and -3 all over 2a, and in this case our a is 2, so this will be 4. And if we multiply all those numbers out, we will get -1 plus or minus radical 1 minus 24 all over 4. And so when we subtract 1 minus 24, we get -1 plus or minus -23. So minus 23 over 4. And so this is one of our zeros. So our zeros would be -1 plus I radical 23 over 4. And since it's imaginary, it comes in a pair, so -1 minus I radical 23 over 4. And we can't forget about our values that gave us our 0 heroes. Those are also included as zeros, so we use -1 and 1, so these will also be zeros, -1 and 1. And to find our factors, we will subtract -1 plus I radical 23 over 4. Like that, and when we solve that out, we get 4x plus 1 minus I radical 23 over 4. And for our second one, we do the same thing. -1 minus I radical 23 over 4. And when we multiply that out, we will get 4x plus 1 plus I radical 23 over 4. And so these right here are two factors. So those are 4x plus 1 minus I radical 23 over 4. And also 4x plus 1 plus I radical 23 over 4.